Hello and welcome back. In this video we'll continue looking at the question that we left off last time, which was trying to solve this equation involving some logarithms. And to go back through the steps, so first of all we looked at our equation, and to get to the next step we saw that we're subtracting logarithms, which means we can combine these into one fraction where the subtraction turns into a division within the logarithm. Next, we know that when the log of a number is equal to the log of a number, those two numbers have to be the same. So we had 1 over x is equal to x plus 2 over 4x plus 3. And because these fractions are hard to deal with, I'll multiply both sides by x so that this term and this term cancel to be left with a 1. And then on this side I just had to multiply the top of the fraction by x. But we still had 4x plus 3 on the bottom of the fraction. So again, I want to multiply both sides by 4x plus 3, so those guys cancel. And what I'm left with is x times x plus 2 is equal to 4x plus 3. And this is mostly just solving a polynomial like we normally would. So I expanded the left-hand side, moved everything over to get x squared minus 2x minus 3 is equal to 0. So this factors into x minus 3 times x plus 1. So we know that x either has to be 3 or negative 1. However, when we're doing a problem with logarithms, we always have to check our original equation, simply because we can get answers that don't really make sense that sort of come out of all of this work. So let's try plugging in 3 first. So let's check x is equal to 3. And let's look at just the left-hand side for the moment. So we have the natural log of x plus 2 minus the natural log of 4x plus 3. The natural log of x plus 2 minus the natural log of 4x plus 3. And we want to substitute 3 in for x to see if this will work. So this over here, 3 plus 2, that's 5. So we have the natural log of 5 minus the natural log of 4 times 3 is 12, plus 3 is 15. And the natural log of 5 minus the natural log of 15, well, again, we can consolidate this into one natural log by recognizing that subtracting natural logs is the same thing as dividing their inside, and this is just going to be the natural log of 1 over 3 once I simplify this. But the natural log of 1 over 3, the right-hand side of this equation is the natural log of 1 over x, and that matches because x is 3. So, yay, we did that correct. Now, the other solution that we found was x is equal to negative 1. What you'll notice is that, let me just look at this left-hand side for a moment. So as we check x is equal to negative 1, the right-hand side is going to be 1 over x. But if I substitute negative 1 into here, I have the natural log of 1 divided by negative 1. Well, that's just the natural log of negative 1. And this can't happen. We're not allowed to take the natural log of a negative number. Logarithms only apply to positive numbers. So this solution is not a solution. Our only solution, so the only solution is x is equal to 3. So after we did all this work, we found two solutions that came from our polynomial in here, but it turns out that only one of them is a true solution to the original question. So the rest of the chapter is basically looking at some applications, so let's go through some word problems. So research indicates that the risk of having a car accident increases exponentially as the concentration of alcohol in the blood increases. So the risk is modeled by this equation right here. So the R is the risk, and this will just be a percentage, and this is equal to 6 times e to the 12.77 times x, where x is the blood alcohol concentration. The question is, what is the blood alcohol concentration? So what is x when we have a 7% risk of having a car accident? Well, so 7% risk means that R is going to be 7, and this is going to be 6 times e to the 12.77 times x. So when they're asking what is the blood alcohol concentration, they're asking for what is x. And this we can solve a fairly straightforward way. So first of all, we have an exponential function. So what we want is the exponential by itself. So I'll just divide both sides by 6 to get 7 divided by 6 is equal to e to the 12.77x. And the trick here is to take the natural log of both sides. And again, why the natural log? Because I have an exponential with e as the base, so I want the logarithm with e as the base, and that's the natural log. And the natural log and an exponential, they both, an exponential with e, they both have e as the base, so these guys will cancel out. So what we're left with is natural log of 7/6 is equal to 12.77x. Again, the natural log of an exponential with e as the base, these cancel out, and we're just left with the power. So x, if I divide both sides by 12.77, I get that x is going to be the natural log of 7/6 divided by 12.77. And here's our answer. We can plug this into a calculator, and we'll get that x is going to be 0.012. So approximately. So this is our answer. You would have to blow a O12 to have a if you have 0.02 or 0.012 blood alcohol concentration, there's a 7% risk of getting into a car accident. So the one other application that we saw previously was looking at interest. So and we saw this formula before. So A here is the accumulated value of some principal that we've invested. So P is the principal. We invested at an interest rate R, and this is expressed as a decimal. But we're not getting this interest back at the end of every year. We're getting it back a certain number of times a year. So we have compounded interest, and we've invested it for T years. So this question asks, so how long to the nearest tenth of a year will it take for our initial principal of 1,000 to grow up to 3,600 when they tell us what rate is being invested at, so this is at 8%, and is compounded quarterly. So let's look at some of these variables. So we know that at the end of our investing, we want to have $3,600. Our initial investment is going to be $1,000. Our rate is going to be 8%, and this as a decimal is going to be 0.08. So this is 8% means 8 out of 100, which is 0.08. And if our investment is compounded quarterly, a quarter of a year, well, there's 4 quarters in a year. So this is going to be compounded 4 times a year. And the question is, how long to the nearest tenth of a year? So we don't know how long to invest at. This is going to be the variable that we want to solve here. So let's plug everything into our equation. So 3,600 will be equal to 1,000 times 1 plus the rate, which is 0.08, divided by the number of times we're compounding each year, all raised to the number of times we're compounding each year times the number of years that we're investing. So again, we have a fairly straightforward exponential over here, but we want to get it by itself. So let's divide both sides by 1,000. And this is fairly straightforward. 3,600 divided by 1,000 is just going to be 3.6. And we want this to be equal to 1 plus 0.08 divided by 4, all raised to the 14. Let's simplify the base here. So this is going to be 3.6. 0.08 divided by 4 is 0.02. So 1 plus 0.02 is 1.02. All is raised to the 4t power. So here, again, we have an exponent up here that I need to bring down. So what I want to do is I want to take the log of both sides. And we've got essentially two choices. We have the common log and the natural log. Since this isn't 10 raised to a power, we normally just choose the natural log. So we have the natural log of 1.02 to the 4t power. And the nice thing is that we have our power rule. So bringing this down, this is the natural log of 3.6 is equal to 4 times t times the natural log of 1.02. So I have to get t by itself. So I have to divide both sides by 4 and by the natural log of 1.02. So divide by 4 and the natural log of 1.02. And our time is going to be the natural log of 3.6 divided by 4 times the natural log of 1.02. Let me put some parentheses in here so that we can see what our natural logs are. And this is it. This is our answer. But they wanted this to the nearest tenth of a year. So we'll have to plug this into a calculator. And doing so, we get about 16.2. So we'll take 16 and a little bit longer, 16 years plus a couple months before we can turn $1,000 into $3,600 at an interest rate of 0.08. And like I've said before, 0.08 is a very high interest rate that would be hard to see in the real world. The last question here, the percentage of an adult height attained by a girl who is X years old can be modeled by this equation. The question is, when will a girl have attained 97% of their adult height? So again, f of x is just going to be this 97%, so it will be 97. X here is just how many years old they are, so we just need to solve for x. So let's write down our equation. 97% is going to be equal to 62 plus 35 times the log of x minus 4. Again, in order to solve this, I need to get the log by itself. So I'll subtract 62 from both sides. 97 minus 62 is going to be 35. This is nice. 35 is going to be equal to 35 times the log of x minus 4. I need to get the log by itself, so again, start shipping things over to the other side. I'm going to divide both sides by 35. 35 divided by 35 is 1. 35 log x minus 4 divided by 35, well, that's just going to be log x minus 4. And here, this is written in logarithmic form, but we can write this as an exponential. This is log base 10. So 10 raised to the first power is going to be equal to x minus 4. And again, 10 to the first power is just 10. And I can add 4 to both sides to get 14. So at age 14, we would expect a girl to have reached 97% of their adult height.